Hello, grade 7. This is Math Lesson 1-9, page 52, numbers 5 through 47, the odds. And guess what? Today's lesson is very similar to yesterday's. Yesterday's was about using inverse operations to solve adding and subtracting problems. Today's lesson is about using inverse operations to solve multiplication and division problems. So the technique is going to be very similar. So let's jump into this and take a look at some example problems. You're probably going to think, wow, yay, I know how to do this. At least hopefully you will. Here's our first problem. 7 times t equals negative 49. Well, the middle of the equation is the equal sign. We need to get t all by itself. But the t is attached to the 7 by multiplication. What's the opposite of multiplying by 7? Dividing by 7. And we're going to divide by 7 on both sides of the equation. And that gives us t because these 7s cancel each other out. And over here, a negative divided by a positive is a negative 7. So here's the kind of work we're doing. See how it's similar to using inverse operations to add or subtract? Yep. Let's try another one. Yay! How about the following problem? W over the top of 6 equals negative 10. The middle of the equation is the equal sign. Where's our variable? It's right here. What is it attached to? It's attached to a 6 by division. What's the opposite of dividing by 6? Multiplying by 6. So my second line looks like this. We're going to multiply both sides by 6, and we get a W, because these two cancel each other out, equaling negative 60. Let's try another one. How about something like this? C over the top of 9 equals negative 6. C over the top of 9 equals negative 6. Or in other words, C divided by 9, that'd be a better way of saying it. C divided by 9 equals negative 6. How am I going to get that C all by its lonesome? Well, if C is attached by division to that 9, what's the opposite of dividing by 9? Multiplying by 9. And we need to do that to both sides of the equation. And when we do that, C is all by itself because these two cancel out. And over here, the answer is negative 54. Not so bad, right? Let's try another one. What about this problem? Negative 4n equals 28. 28, or 28, if you want to speak English. Well, the variable is this n. It's attached to the negative 4 by multiplication. We're using opposite operations or inverse operations. What's the opposite of multiplying by negative 4? How about dividing by negative 4? And we're going to divide both sides by negative 4. Over here, we're left with n because these two cancel out. Over here, we're left with negative 7 because a positive divided by a negative is always a negative. How about this one? Negative 12 equals a negative 6 times k. A negative 12 equals a negative 6 times k. What is our variable attached to? It's attached to the negative 6. How is it attached to the negative 6? By multiplication. Yep. So, what's the opposite of multiplying by negative 6? How about dividing by negative 6? And what do we get? We get 2 equaling k. A negative divided by a negative is always a positive. And over here, the negative 6's cancel out, leaving us with a k. Very similar to yesterday's assignment, isn't it? Instead of adding or subtracting, today we're multiplying or dividing. Let's try another one. How about this one? How about m divided by 40 equals negative 4? M divided by 40 equals negative 4. Well, the variable is m. It's on the left side of the equation. It's attached to the 40 by division. What's the opposite of dividing by 40? The opposite of dividing by 40 is multiplying by 40. So I'm going to do that to both sides of the equation. And when I do that, I get m on this side because the 40s cancel off. And on this side, I end up with negative 160. How are we doing? Does this make sense? Hopefully it should. Shouldn't be that big of a deal. If you have any questions, go ahead and ask. Have a good day.